then send it to you. Right, I'm recording now.
Okay.
Okay. Network. Network is interconnected computers or computing devices for the purpose of, so one important role is sharing resources, as I said, I'll highlight. And the second important role is communication. And it can be connected. The computers can be connected via, so one, wired media or wireless media. Can you give few examples for wired and wireless media? Wired media. What kind of wired media can be used? Yeah. What kind of wired? There are three basic. There are three basic things which can be used. Yes. So but that is not related to this. The wired media. So one is coaxial cable. Coaxial cable, which is similar to antenna cable in your TV. Then you have twisted pair and fiber optics. Coaxial cable is a copper cable, which is similar to the antenna cable, and twisted pair means 4 pairs of cables. 2 by 2 it is twisted, right? 2 by 2 it is twisted. Let me show image if you have not seen. This is twisted pair and coaxial and fiber optics. So you can just Google these things. Therefore, I'm not going to repeat this again and again. And these are the three types. So coaxial cable, which is similar to the antenna cable, you can see the copper wire here. This white color one is called inner insulation. Right? White color one is called inner insulation. Then you have copper mesh. I think you have learned this in the maybe lower grades, no?
Yeah.
The only thing is you have to remind this, okay? Then you have copper mesh. Copper mesh is protecting from external electromagnetic interference. Why copper mesh is used? Because you know when there's a power going through a wire, there will be a magnetic field created inside that. So magnetic field created, not inside actually. Magnetic field created according to the power, right? So this magnetic field can be interfered by external magnetic fields. So these, the electrons are traveling now. So if power is in going this direction to this direction, bottom to top, if power is traveling from bottom to top, then electrons are traveling from top to bottom, the other way. Right? Anyway, these electrons are affected by electromagnetic interference. That is called resistance ultimately. It will create resistance. So therefore, this copper mesh is there to protect that from external interference. And then you have outside insulation layer.
Right.
Okay. Twisted pair. Why twisted pair? These pairs are twisted. Twisted means those are actually twisted. 2 by 2 twisted. Why? The reason is, the magnetic field created by one cable can be neutralized by using opposite magnetic field. If you have magnet which has north south and another magnet which is in the opposite direction, in between you can create that one magnetic field created by one magnet can be neutralized by the other magnet. So similar to that, so one side that this is twisted, because of this twist, there will be opposite direction magnetic fields which will be cut off. That's why, again, to stop the electromagnetic interference, you have twisted. Then fiber optic, it doesn't have something called electromagnetic interference. Why? Fiber optic? Fiber optics, you don't have something called electromagnetic interference. The reason is fiber optic use light, no?
Oh, right.
Correct or wrong?
Yes, yes,
Yeah.
yes.
Both of these copper wires, both these copper wires are using electrons, but this one is using light to send data. So the advantage is no electromagnetic interference from outside, and you can send data long direction or long distance using
Right.
fiber optic cable. Coaxial cable maximum will be 100 meters or 200 meters. Again, this one 100 meters or 200 meters. That is the maximum. That is the copper wire. No, copper wire you can send only limited meters.
Right.
Only if you maintain the quality, it is 100 meters basically. But fiber optics you can even send 50 kilometers. Right? Fiber
Uh-huh.
50 kilometers because very low in electromagnetic interference. Oh, actually, zero electromagnetic interference we call, but it is not happening. No, nothing with zero interference. Nothing can be there with zero interference. Then you can just send signal to infinity, but that's not going to happen. So anyway, you have a few electromagnetic interferences or any kind of resistances because of the bends and all. So anyway, this can travel like 50 kilometers. Okay.
Yeah.
Let's get back to this, and I'll just write this. It's like 100 meters. So this is also the twisted pair. You can send data again around 100 meters. These are the basics actually, but I'm repeating these. And then fiber optics also. So, but it is 50 kilometer, very long distance because it's using light. And right then, so you know what is network, and network can be connected using wired or wireless media. It is computers or computing devices basically. What is internet then? What is internet? What is internet?
Mm, it's a large form of network.
Yeah, it is a kind of large network. We call it is the world's largest network. We call world
Right.
largest public area network or world's largest wide area network belongs to the public, belongs to the public. So why we are telling like that? World's largest wide area network. I think you know about these things. These are some extra things. So here also I gave you extra things. I'll highlight it, extra things in green color. Then you can later know this is extra. This is the note and this is extra. Again, this is internet. Something to discuss extra. What is WAN?
A wireless network. A wired network.
WAN
A
is wide
wired.
area network, right? WAN is wide area network. So what is
Uh,
LAN? What is
a
MAN?
local area.
Yeah, LAN means local area network. So what's the difference? Local area network, it is limited to a single geographical location. Limited to a single geographical location. Means limited to maybe a room, limited to a building. Single geographical location means that geographically you cannot see any, you cannot feel any differences in the particular area. For an example, assume the geographical area in your house. So actually, may I know where your house is located?
Uh, Palmaster.
Pallath.
Yeah.
Yeah. Okay. Think that your home or your hometown, you will get different maybe different environment situation. Like you will get maybe rainy day, but at the same time, I'm in Gampaha. In this area, I will feel some normal weather without any rain. So anyway,
Mm,
geographically, we are in two areas geographically. So sometimes if I'm there in the Kandy, it is another area geographically, it's another different area. Geographically, you can see the differences, no? But in local area
yeah.
network, you cannot see any differences geographically. It is in a single area, single building or single room, single classroom in your school, maybe in a university. It's a local area network. So what is MAN? And here WAN means connecting different geographical areas. So now my machine and your machine is connected, but now we are in wide area network. Why? So we are in two different geographical area networks. Geographically, we are in two different locations. Therefore,
Yeah.
we belongs to WAN, wide area network. Local area network,
Right.
your own area, you own. So what is MAN? MAN means municipal or metropolitan area network. So what is metropolitan or municipal area network? It's a
Mm.
network within a city or village. Geographically, you cannot say geographically it is a, you cannot even say geographically single area, but it is not different geographically. It's not a different area as well. For an example, in Colombo City, there are Colombo 1, Colombo 2, Colombo 3, you know, different regions are there. But
Yeah.
when you take as a city, it's Colombo City. So you can
Yeah.
form a city network in Colombo City, which is called Metropolitan Area Network. In addition to that, you have some other networks like DAN or Desktop Area Network. That means network within your desktop. You can just connect two laptops, keeping in your desktop. It is called DAN, Desktop Area Network. You have PAN, Personal Area Network, means you can connect your mobile phone with another mobile phone, or you can connect your mobile phone with computer. So that is called personal area network. Then you have a SOHO networks. We call small office, home office. You know, some people, they have office attached to their house. Some people, they are doing businesses, they have office attached to their house. So that is called SOHO network. If you are not touching, you call a SOHO network. And CAN means controller area network. What is control area network? You know, network within a car.
What's it?
Network within a car, inside car, network inside a flight, network inside
Oh.
yeah, network is inside the rocket, network inside a ship.
Right.
Likewise, there can be isolated controller area. That means your car dashboard is connected to fuel system. It's connected to tires. It indicates the pressure level of tires. It indicates the fuel level of the fuel tank. It indicates the brake system. Likewise, everything is there connected to dashboard, no, in the car.
Right.
So that is called control area network. Similar to that, there are dashboards in flights, trains, ships, rockets. There are dashboards. So those are called controller area network.
Right.
Okay, understood. These are some extra things that you have to learn. Another one, there's something called SAN. SAN called storage area network. SAN called storage area network. So where hard disks are connected using SAN has something called NAS, network attached storages. SAN has something called NAS, network attached storages. So that is another terminology. Anyway, SAN means storage area network, where you have hard disks or the storages connected. Why you have to connect network hard disks? What's the reason? Generally, what's the reason? Think about
storage.
Yeah.
It has something to do with storage.
Yeah, there's something to do with storage. That's true. But the thing is that, so assume that you have hard disk. It's only 1 TB, 1 terabyte hard disk. So now you want to change that to 2 terabyte hard disk. Now you want to increase your hard disk capacity
Oh,
to
okay.
2 terabyte. What you are going to do normally? You turn off the machine, plug the new hard disk, attach a new hard disk and turn on. Can you do the same thing in a
Yeah.
server environment?
In a what, sir?
Can you do the same thing in server environment? Server environment, can you do that? Turn off the
No,
server, plug the hard disk, turn on again and start working. Can you do that?
I don't know.
Why?
Because if we shut down the whole server just for that, that would be not
If you
practical.
shut down whole server, entire network will get affected. So for an example,
Yeah.
think about you are connected to Google Cloud Server and they are going to update their hard disk capacity. They shut down their machines and start attach another hard disk and start again. Then what will happen? Then at that time, no one will receive the Google service, no? Therefore,
Right.
practically servers you can't shut down. And therefore, what you're doing in storage, especially, they are attaching new hard disk to the storage network. So automatically that will be because of this network attached storages, because of NAS network attached storages. What will happen? Automatically the capacity will be increased, but that is due to the networking. So no need to turn off, change the hard disk, and restart. Likewise, you don't need to do that. Hopefully you understood why
Right.
storage area networks are there. All right, okay. Then,
Yeah. Sir, could you give me a minute to copy all this?
okay. Anyway, if you want, I can send this note.
Right. Could you, sir?
Yeah, I can forward this through the chat.
Okay, sir.
So I think that will be easy, no? Otherwise, then we can save some
Yeah.
time. Yeah, we can save some.
Yeah, sir.
Okay, then if you have questions, please ask. So I'm doing this from using very basics. These are actually very basics, but
Right.
I'm reminding this before we begin. I'm going to remind this. So internet is called world's largest wide area network. Wide area network means it's in different geographical areas, and world's largest wide area network. It belongs to the public. That means no one else on internet. It's actually owned by the public. It belongs to general public. So that is the largest network
Right.
belongs to the general public, that is internet. When you connect to internet, you can also access. When I connect to internet, I can also access. There are no restrictions. Anyone can connect to the internet and access it. But
Yeah.
behind that, there are people called IETF. IETF means Internet Engineering Task Force, and they are responsible to maintain this facility. IETF,
Right.
engineering. Otherwise, so no one is going to that. Even though we are using internet, we are not going to maintain it. No, okay.
Yeah.
Maintaining part is done by or maintaining or policy forming or whatever the procedures. All these are done by a set of a group of people called Internet Engineering Task Force. Right.
Right.
So then next thing is we have to learn protocol. Okay, protocol is simply a set of rules in networked communication or set of rules used in network communication. So network communication means what we are doing now is network communication. I'm talking to you through Zoom, which the application is passing my details to you using internet. Okay.
Yeah.
But before we pass this information, we have to agree on a set of rules. That is not strict rules, but anyway, we have to agree what time we are supposed to deliver what time I'm supposed to deliver the lecture.
Right.
Then the next thing is what time you are supposed to participate and what is the language that we are going to use, what chapter we are discussing on. And likewise, we will be agreeing on some rules. No? Then only we can
Yeah.
effectively communicate. No? Then only we can
Right.
effectively communicate with each other. So that is going to happen in the network environment. Assume that two computers are connected. Your mobile phone and your laptop is connected. Now, both your mobile phone and laptop should agree with some set of rules before communication. Otherwise, it's not going to be effective communication, because even your laptop is going to send bulk data bulk to your mobile phone. Sometimes your mobile phone is not powerful enough to get that bulk. In that case,
Right.
what will happen? That communication will not be effective. So in order to make this effective, in order to make this effective, what do you have to do? So both this mobile phone and laptop should agree on data speed. And not only that, data encoding format. How many bits or how many kilobits will be sent for a particular minute, and what is the encryption or decryption algorithm, encoding and decoding methodologies. All these things should be inside the agreement between the laptop and mobile phone. So that is called a protocol. So we have discussed few terms here. So what is encoding? So these are extra things. That's why I'm telling. So if you have like doubtful terms, please ask from me. What is encoding?
Yes, sir.
What is decoding? What is encryption? So what is decryption? So these are some terms that we talked. So we have to agree with encoding, decoding mechanisms, encryption, decryption algorithms. What is encoding? Encoding means so data is represented using some format.
Data.
Yeah, data is represented using some format. That's why 3.1. So that's why we had 3.1. That's why I asked whether we want to discuss 3.1 and come to this point. If we discuss 3.1, you know what is encoding. For an example, A. Yeah, letter A. In ASCII, American Standard Code for Information Interchange, this is 65. Example, right? A in ASCII is 65. That is encoding. Right? So we have given value to A in ASCII. So are you using a laptop or using a mobile phone to watch this?
Mobile.
Mobile phone, no? So if you are using, so you don't have power, no? There, still?
We have power now.
You have power. So, okay, later you can do this, huh? Later you can do this. Just press Alt key, ALT, you know, ALT?
Yeah.
Right. Alt plus, you know numpad, no? Numlock?
Yeah.
In numlock pad, just press numpad 65.
Okay.
Numpad 65. Alt plus numpad 65. Then you can see letter A will be displayed. If you go to Word and press Alt 65, you can see letter A. The reason is 65 is the ASCII value for A, but that is not the Unicode value. When you go to Unicode, so let's go to Google and ask Unicode value of A. Unicode value of A, you can see this is the Unicode table. This is Unicode table. Then if you check ASCII value of A, here this one, let me zoom. It's not clear, sorry. This is ASCII. Unicode.
Right.
Okay, you can you see this table? Blurred.
Yeah.
Blurred, no?
A bit blurry, but I can see a bit.
Yeah, it's a bit blurred, but
yeah.
Okay, because I can also see it's bit blurred. Here 65, let me read. 65 is letter A. 65 is letter A. Okay, then if I go this one, here again 0041 again,
Right.
65. Unicode also the value is 65. Right? But ASCII, you can see ASCII, you have now you can see this, no? A is 65. In hexa, it is
Right.
41. In octal, it is 101. This is A. Decimal, it is 65. Right? So let me go to this one. Here, this is Unicode. In Unicode, it is 0041 in hexa. Again, 65, 0041. Right? But Unicode, you have many characters than ASCII. Anyway, this is called encoding.
Right.
This is called encoding. Okay, let me do something else. I'm going to Google. Then I'm going to search using my name. I'm going to search my name. Dasun Nilanjana. Right. So then I get some results. Can you see the URL? This one.
Yes.
What is there? Can you read and understand quickly? Quite difficult, no?
Yeah.
Difficult to read and understand. But I'll go to some other area. Like, okay, let's go here. Okay. So I'll forward this a little. Okay. Now can you see something here?
Yeah.
Dasun plus Nilanjana, OQ Dasun plus Nilanjana, right? So
Yeah.
this URL is encoded. Encoded means it has some data which you cannot directly read. It is encoded according to some format. Encoded means it is represented by using its own code, a mechanism. This is called URL encoding. This Dasun plus Nilanjana, but still you can see some Dasun plus Nilanjana. Let me change this to 3 pluses. Then you can see 3 spaces here.
Oh.
Isn't it?
Yeah.
I added 3 pluses there, then 3 spaces. Likewise, so some encoded part, yes, we can understand. Plus means then plus means space. Then I'll search here Dasun Nilanjana plus photography because it's my hobby. Okay. Dasun plus Nilanjana plus photography. You can see this will be edited to Dasun Nilanjana photography. Right?
Oh.
Okay, so that is the practical side of it. Encoding. Why encoding? Because you want to represent the format, represent our whatever readable format. So from some other characters, encoding. But this decoding means decoding. Encode. You include it in URL.
It would be the opposite of encoding. So the
is encoded in URL. What has happened?
To retrieve proper data from that.
Yeah. This is here. You can see this is when I selected. This is only one string, no? Only one string.
Yeah.
One text. But inside that, these parts are encoded. Dasun Nilanjana photography. This part is encoded to this one string. But when I change this or when I type this, it will be decoded and shown here. This is the decoded version of this encoded string. Encoded string, that is one thing. Encoding means you code into one thing. Decoding means from that you extract the data that you need. Extract the data that you need. That is called decoding. And encode means encode it to one. Decode means divide it to the specific areas. Then you can see it is divided to this is search string. So these characters represent some other thing. Maybe it represent our browser. It represent the time I search or how many times I have searched, what kind of browser I'm using, what kind of machine I am using, what is the resolution of my screen, what is the operating system of my computer. Likewise, all this information are encoded information encoded into a single URL. You call URL, Uniform Resource Locator. But when you're reading back, it will be decoded and shown you. It will be decoded and you can see the decoded version of this encoded URL. But some parts, not everything. Some decoded parts you can see. Okay, encryption. Encryption means something else. Right? Encoding, decoding, then encryption is something else. Right? Encryption is something else. So let me show one example. Okay, decoding, maybe change encoded. You can see this A is encoded to 65, but when you type 65, it will be decoded to A. That is something. But encoding, encoding you don't have secrets. Huh? Encoding, the mechanism is public. Anyone can encode, anyone can decode it. Encode, code. I'll simplify this. Code into one string or code into one scheme. Right? Then change encoded one to normal messages. Encryption is, it has secret. Encryption means converting plain text to ciphertext. Converting plain text to ciphertext. Plain text means readable text. Ciphertext means unreadable. Secret message. Decryption means the other way. Decryption is other way. Decryption means converting ciphertext to plain text. Converting ciphertext to plain text is called decryption. Converting ciphertext to plain text. So what do you really mean by this? Okay, so let me write something. I want to meet you tomorrow. This is a message. I want to meet you tomorrow. In encryption, okay, I'm going to write this like this. I space, okay, I then space W A N T want W A N I want again space to again space meet M E E T space Y O U space T O M O R R O W. You understood what I did, no?
Yeah.
I wrote this downwards. I wrote this downwards. Now I'm going to merge this into a single string. Okay, can you read this message?
No.
The way we did is a secret, no? The way we did it.
Yeah.
So if I am sending this message to someone, definitely he or she will not be able to read this. But if they know the algorithm that I have used, the secret algorithm that I have used, which is called, actually, I have used a disposition algorithm. I have changed the position of the letters. I have used the disposition algorithm. If they know the disposition algorithm that I have used, then they can read that. So anyway, that method is a secret. You know, this was earlier used by Julius Caesar. When there was a war, he wanted to send his messages to the other party or his people in other areas. So initially he was sending the messages, but the enemies, they were capturing his soldiers and reading the messages. So that was a headache for him. Therefore, he has applied something called monoalphabetic Caesar cipher. Monoalphabetic Caesar cipher means something like this. If there's a message like hello, so what he did is HIEFLMLMOP. He was sending this by substitution. That means he has used another character to represent the original character. That is called substitution. Here we have used disposition. Those are two primary techniques. Okay, substitution means you represent one character by some other character. Disposition means use the same character, but you change the position of the character. Right? If you have computer security, don't worry. This is also belongs to theory part. In computer security part, you have to know what is substitution, change in letters. What is disposition? You change the position of the letters. So if you apply both, if you if you have use disposition and then apply substitution, then it will be very difficult, no? So if I'm going to apply this string, I'm going to change it according to Julius Caesar cipher. J space maybe some other character, then E F dot R S. Likewise, I'm going to change this using substitution. Then again, it is really difficult to find the message. So anyway, encryption and decryption is used to data hiding. It's used for data hiding. Understood? Encoding and decoding is used to data representation. Right? Those are two things. Sometimes you might confuse. Encoding and decoding is used for data representation. Encryption and decryption are used for secure the confidentiality. This is just for representation. This is for making messages confidential. Understood? So inside the protocol, you agree with certain encoding, decoding, encryption, decryption, communication mechanisms. So which is actually basically in generally we call a set of rules used in network communication is a protocol. So no need to remember all these things anyway. So if I erase these things, it is just a set of rules used in network communication. Why set of rules used? That is the agreement between two parties or the parties which are communicating. Understood? Understood?
Right, sir.
Yeah, understood. If you have any
Yes,
doubt,
sir.
yeah, please ask. Any doubts, please ask, because I'm thinking that you have not done these things. That's why I'm repeating everything. It will take some time. That's why I said. So then, so if you can share me maybe snapshots of your book, or if you can share me the soft copy of the book, then I can refer and go according to the book. But the thing is, these parts also required. Okay, then, right, then let's learn more about the protocols. What are the protocols used in internet? What are the protocols used in the internet? So what kind of protocols are used in the internet? Basic protocol suite used in internet is called TCP, IP. So meaning of TCP IP? What's the meaning of TCP? What's the meaning of IP?
I think.
Yes.
The IP is Internet Protocol.
Yeah, IP is Internet Protocol. Yes, TCP.
Transmission Control Protocol.
Yeah, it's Transmission Control Protocol. So two things. TCP means Transmission Control Protocol. And the second one is called internet protocol. Right? First one is called transmission control protocol. The next one is called internet protocol. Okay, right. So basically, so this transmission control protocol, it is responsible, this TCP, these protocols are working together. So let me write, these protocols are working together to establish connections in the internet, providing the infrastructure to other protocols, especially in the application layer. So this, okay, these protocols are working together to establish connections in the internet. Right? These protocols, these two protocols are working together to establish connection in the internet, providing the infrastructure. Infrastructure means it is the basic foundation to other protocols. On top of the TCP/IP, then other protocols like HTTP, hypertext transfer protocol, HTTPS, hypertext transfer protocol, secure version, FTP, file transfer protocol, simple mail transfer protocol, internet message access protocol, post office protocol or post office protocol version 3, then other protocols, the application layer protocols are working on top of the TCP/IP protocol suite. Okay, this is the foundation. These are the bridges or the building blocks. On top of this foundation, these applications are working. These two for web. This is for file transfer. These three for email. And there are some more for remote access. You have telnet and all. Likewise, they are also working on top of internet TCP/IP protocol suite. So let me explain this protocol suite more carefully. TCP does these things. It ensures reliable delivery of the packets. So what is packet? Packet means small chunks. Small chunks
of data.
Why you have small chunks of data? Assume that you are given a loaf of bread and maybe you are given a piece of bread, and it is not possible to swallow it at once because you know the limitations of your throat and your digesting system. It is not possible to swallow that whole thing at once. Therefore, you divide it to small pieces. Then only you can swallow it. Otherwise, it will stuck in the middle. Isn't that so? If you are not going to divide
Right.
piece of bread into small chunks, what will happen? It will stuck. It will stuck. That is similar to data. So you can't send a film at once. You have to divide that film to small packets or small chunks. Then only you can transport that to the network. Right? Then TCP ensures reliable delivery means it ensures that these small packets, whether all packets are sent, whether all these packets are received properly, whether there's any damage of these packets, whether there are any missing packets. In case of missing packets, need to resend. And packet reordering. So because in sometimes the packets are not received according to the order, because internet is unreliable environment. Since it is unreliable environment, you have to load you have to reorder that. So in case of missing or damaged packets, you have to replace or ask the sender to send it back. That part is played by TCP. TCP is the guard. Actually, we call TCP is a virtual circuit packet switching. TCP is a virtual circuit packet switching protocol. Virtual circuit packet switching means, so actually it established a virtual circuit over the network. Okay, I think you, in order to give you that idea, what is virtual circuit, you know the bus routes, no? You have bus routes like 101, more to 100 and 100, 400. Likewise, you have bus routes, no? These bus routes, they have never marked in the road, ne? They have never marked that in the road, no? That is virtually, ne? Virtually that bus goes,
Yeah.
virtually that bus travels and turns from this junction, maybe junction A, it will turn right, then junction B, it will turn left. But there's another bus. That bus is from junction A, it is turn in some other side. So you give another route to that bus, but travel in same direction. For an example, Moroto, you have two kind of buses, no? Basically 100, 101. So as I remember, I'm not sure whether I'm telling the truth, because long ago I came Colombo and I got to know that 100 is also Moroto, 101 is also Moroto route, but two routes basically. Likewise, those are virtually, no? Those are virtually formed, not actually. Those are virtually formed. So that is called virtual circuit. That means in internet is like it's a complex connection. It's a complex environment. You have multiple way to get multiple way to go particular destination. Assume that you are traveling from Colombo to Kandy. One route is you have Kandy Road. Right. So second one is you can go to Kurunagala and then go to Kandy. Or you can go via 99, that 99 road, and you can go to maybe Kegol or maybe Ginigatteno somewhere, and then turn and come back to Kandy via Navalapiti or some other area. Likewise, there are different routes, no? Right? When you send the packets, when you send the packets in this unreliable environment, they will go here and there. They will try to find the easiest way, easiest path or the less traffic path, and they are going here and there. And finally, they will come to the destination. But what TCP does, TCP will go and establish a pre-circuit. Then packets will not follow different paths. Packets will follow the same path. Understood? It will go and establish a path. Okay, assume that you are traveling from Colombo to Kandy. It will go and establish a path. You should go to Kurunegala and then go to Kandy. It will establish the path. Then assume that there's a bicycle race. Then all cyclists, they must pass Kurunegala and go to Kandy, because that route is defined. Right?
Right.
Understood?
Yes.
Understood or doubtfully?
Yes, sir.
Okay.
So could you give me a 1 minute?
Okay. Okay, then virtual circuit, you know that virtual circuit is something where you pre-establish the circuit and then go. Okay, to explain this more carefully, I'll give some extra things, again, extra things. Even though I'm discussing these extra things, please actually note that this is again, they are in your syllabus, right? According to your syllabus, I went through. So this is again, they are in your syllabus. Okay. The extra thing is something like this. Okay. So what is circuit switching? What is circuit switching? And what is packet switching? What is circuit switching? What is packet switching? What's the difference? Basically, let me give you some ideas. Circuit switching used in telephones. Packet switching used in networks or data networks. Circuit switching used in telephone, packet switching used in data networks. Basically in traditional telephones, not database, not IP based phones, traditional telephones, circuit switching is used.
Right.
What's the difference? Something like that. Okay, something like that. Okay, so assume that you are going to take a call in landline. Think about traditional old landline system. So you want to take a call. When you are in the call, can some another person call you? Think about traditional landline,
No.
traditional telephone. When you are in the call, can another person call
in a landline, yes.
Can another person call at the same time?
In a landline, no.
No. Not possible. Why?
If they're using, if the landlines are linked.
Yeah, don't think about this call waiting and group calling, call conferencing. Don't think about that. Just think about the fundamental or the basics. Basically, when you are in a call, in your landline or telephone line, some other person cannot call you unless you put wait in no conference or whatever. Right? If there are no special purpose, no specific purpose, so then that circuit is called circuit switching. That means there's a circuit between caller and call. There's assume that Bob is calling Alice. Then there will be a circuit between Bob and Alice. At that time, Truder cannot come to middle and he also join call. No, it is not possible. Truder cannot call to Bob. Truder cannot call to Alice as well, because both parties are engaged already. They are in the connection. When you drop that connection, when Bob keep the phone and then Alice also keep the phone, then Truder can call Bob or Alice. That is the traditional scenario, no? Or you have three people, A, B, C, A, B, and C. A and B are calling each other using traditional telephone. Then C cannot call to A, C cannot call to B. But after that calling process, both A and B will keep the phone. Then C can call A or B, anyone. So that means there will be a circuit between that call time, there will be a circuit. But in data, is it the same? In packet switching, is it the same? When you are downloading a YouTube or when you are watching a movie, can you download a torrent movie? When you are watching a movie, can you listen to a music streaming? Possible,
no? Yeah, it's possible.
Yeah. In when you are assume that you are downloading music from you are downloading application in your app store or Play Store. You are downloading application. At the same time, can you play a music using YouTube? Yeah, it's possible. If your data connection is strong enough, then definitely it will support both kind of data operations, because in data you don't have such thing. That is packet switching, because all are packets. Only thing is you have something called bandwidth. Bandwidth means width of the particular, or the capacity of the particular channel or capacity of the particular connection. How many bits or how many bytes you can send in a given time. How many bits, how many bytes you can. If your bandwidth is not full, then you can download any number of. If your bandwidth is already gone, then you can't start another connection. Maybe it will drop. It will drop the connection, or it will say that cannot access. Likewise, it will give an error message. But if your bandwidth is there, you can access any number of, you can keep any number of concurrent connections. That is data.
Right.
Understood. But in calls, you can't do the same thing. Calls, after one call,
Yes.
you can go for another call. So that is the difference between circuit switching and packet switching. And you have something called virtual circuit packet switching.
Yeah.
Means you will establish a circuit, but that is a virtual circuit. Through that, you do the packet switching. That means you pre-establish the path and send in packets. So this is there in TCP. Understood? TCP uses both virtual circuit as well as packet switching.
Yes.
Okay, so this is again extra. Right, now we know few things. We know TCP and the fact actually today the last topic that I want to present you is IP, Internet Protocol. Internet Protocol. That is the last topic that I'm going to present. So even though these are theories, actually these are really related to your real network environment, internet environment. So Internet Protocol, it assigns IP address for each network interface. It will assign IP address for each network interface. It has something called Internet Protocol address. And it does something called packet switching. Packet switching means what? Packet switching means it is the one responsible for generating these packets and then switch it using the TCP, or there are sometimes there's an additional protocol called UDP. UDP is a kind of this protocol is called user data tram protocol. It is not like unlike TCP, it delivers packets without ensuring the delivery, ensuring the reliable delivery. So basically, I call this actually these two protocols in my language. I call this like bus, or this like a bus route protocol, but this is like a three-wheel or tuk-tuk protocol. Why I'm telling like that? You know, bus has a route. No? Bus has a route. It will go according to the particular route only. Even though there's a traffic, it will follow the same route. But what about tuk-tuk or taxi or three-wheel? If there's a traffic, it might even go other direction and it will try to bypass the traffic using some other route. It doesn't have defined route, no? It doesn't have a defined route. It will try to go any route and complete the trip. So similar to that, UDP tries to finish the delivery anyhow. It will not think about reliable delivery, delivering of packets, whether all packets are received in the order, all packets follow the same path or not. It will not think about those things. When someone has to deliver data, it will go and deliver that. Basically, this is used in video streaming. This is using video streaming. For an example, I'm talking to you now. Sometimes you might not heard some terms. Sometimes our internet connection will drop. Yeah, sometimes you might not heard the terms. But that doesn't repeat, no? The protocol will not think about repeating that missing parts. I have to repeat that. Right? You asking from me, no? when I got some error or when I got some issue, when our connection got struck, you again ask me to repeat that. Because protocol will not ensure that.
Yeah.
Protocol will just do the delivering part. Because video streaming is like need to be faster. Video streaming need to be faster. Otherwise, it is not possible to deliver it real time. Therefore, this doesn't use
Right.
UDP doesn't use reliable delivery. Mainly used in video streaming, sending data which doesn't require reliability. When sending data that doesn't need reliability, it is using UDP, TCP and UDP works. But TCP and IP, these two protocols are working especially to ensure a reliable delivery. This is a decent service. This is not decent, but still you need this service as well. Understood? Okay, anyway, IP ensures IP is internet protocol. It ensures the packet switching as well as it assigns the special thing that you should know is it assigns IP address, something called IP address. And let me explain about IP address, IP version 4 address, IP version 4 or V4 address. I call that as a 32-bit 4-portion dotted octet binary number represented in decimal. So maybe a bit technical, but still, so this is the reality. It has 32 bits, 4 portions, dotted octet, and it is a binary number, and it is represented in decimal. So that's why again data representation was required. Anyway, try to understand this. 32 bit. Bit means binary digit. What is binary digit? What is a binary digit? Binary digit means 0 or 1.
Can only contain either ones or zero.
Yeah, ones and zeros. Bit means binary digit. Binary digit means
It can only contain ones and zeros, sir.
yeah. Bit means binary digit means 0 or 1. Single digit means 0 or 1. So it has 32 bits. Okay, minimum 32 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. 32 bit, 4 portion. 4 portion. So 4 places. Dotted octet. 8 by 8, it has dots. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 by 8, it has dots. 4 portions. Now we can see 1, 2, 3, 4 portions, dotted octet, binary number represented in decimal. What is 8 zeros in decimal? 8 zeros in decimal is 0, no? No value, no? Here also no value. No value, no value. So IP address of this, the minimum IP address is 0.0.0.0. Let me go to the maximum.
Yeah.
Maximum will be so what is the decimal value? What is the decimal value of 8? This 8. Can you remember how to calculate? This is 2 to the power 0. 2 to the power 0 means ones. This is 2 to the power 1. 2 to the power 1 means twos. Then here, 2 to the power. Can you remember the binary number system? That's why I said the data representation is really required to go to this level. Can you remember or can't? Can or cannot? Hello? Can you hear me? Okay, 8 zeros in binary. What is the value in decimal? What is the value in decimal?
0.
0, yeah. If it is in binary, if it is 1, 1, 1, 1, 1, 1, 1, 1, what is the value in decimal?
How many ones, sir?
8 ones. How you basically calculate these 8 positions?
Using the 2 to the power of 1.
Yeah, 2 to the power, using the positional value. The first position is 2 to the power 0. 2 to the power 0 means 2 to its power 0 means any number to its power 0 is equivalent to this is 2 to the power 0. Then you have 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 6, 7. Here you have 7. Sorry. 7, 6, 5, 4, 3, 2, 1 and 0, no? Hopefully you can remember this. So what is the value of this? 2 to the power 0 is 1. 2 to the power 2 is, 2 to the power 1 is 2. Any number to its power 0 is 1. Any number to its power 1 is the same number. 2 to the power 1 is 2. 2 to the power 2 is 2 into 2, which means 2 into 2 is 4. Then 2 to the power 3 is 2 into 2 into 2 is 8. Again, 16. It always double, 16. Right? 1, 2, 4, double of 4 is 8, double of 8 is 16, then 32, then you have 64, then you have 128. So you can remember this is how the all the devices, computer related hardware devices, basically capacities 1 GB, then you have 2 GB, then you have 4 GB RAM, 8 GB RAM, 16 GB RAM. Likewise, if it is a pen drive, 1 GB, 2 GB, 4 GB, 8 GB, 16 GB. That's how this increase in always double according to these binary patterns. So anyway, these are the values of all these digits. So then you have to add. You have to add all digits. Then 128 plus 64 is 192. 192 plus 32 is 224, 224. 224 plus 16 is 240. 240 plus 8 is 248. 248 plus 4 is 252. 252 plus 2 is 254. Then you have to add 1, 255. So this value in decimal is 255. Okay.
Yeah.
Right. Then, so you can write this IP address as 255.255.255.255, and that is the maximum IP Theoretical maximum IP is 255.255.255.255. Theoretical minimum IP is 0.0.0.0. Practically, we cannot use this one or this one. Practically, we have different IP ranges called class A IP, B IP, class C IP, then class D IP, E IP. We have different classes. And also we have something called CIDR, classless interdomain routing. Classless interdomain routing or class full. Class full means you have class A, class B, class C, class D, and class E IPs. So these are two things. I invite you to search on those things. So these two things, and basically you have to search CIDR and IP classes. So let me know next day, tomorrow, class A, B, C, D, E. What are these classes? So this is for IP version 4. Okay, can you tell me this is this a valid IP address? One, is it a valid IP address? Is it valid?
No.
Why?
It's
between
short.
0 and 255 here. 0 and 255. This is valid. 0 and 255. This is valid. This is valid. This is valid IP. You can represent this using this notation, no? 178. Let's say 168. Or
right.
178 you can represent. So what about this one? Is this valid IP?
No.
Why?
Because there's a 432.
This is not valid. This is invalid. You can't use this number. So how to find IP of your computer? How to find IP address of your computer?
By going to the networking settings.
Yeah, you can go to the network properties and find, or if it is a Linux machine or Mac, so you can type the command ifconfig. ifconfig. If it is a Windows machine, you can type ipconfig. If it is a Windows machine, you can type ipconfig. If it is Linux machine, you can find ifconfig, and this is my IP 192.168.8.103. And there are another two things that is called public IP and private IP. So private IP means something that. So do you have pet name in your home? Any pet name? No.
No.
You are. That means you have your public IP and private IP same. You are like a server,
so.
right? So there are people, they are having a local name. Some people, they are having a local name which is given to their actually house only. They recognize them as like even son, daughter. You can tell son or daughter, that is just for your house, no. But when you go out, there's another name to recognize you. So similar to that, in my computer, in my local network, my computer will recognize me as, in my local network, it is 192.168.8.103. This is in my local area network, LAN site. But when I go WAN site, wide area network, which means internet, and ask what is my IP, it says your IP is 157.157.47.184. Okay, this is how internet recognized me, or a public network recognized me. That is called public IP. How a public network recognize a machine in that network is called public IP. But how a local machine recognized in a local network, it is called private IP. Understood? Public IP means in the wide area network or public network, how the computer is basically how it is recognized in the internet. But how it is recognized in the local environment is called private address, private IP address. So if you know public IP address, you can directly access the particular website. For an example, I can just put this command.
Right.
I can put ping www.google.com. Now you can see I'm getting a reply. I'm getting reply from this address. Can you see? Here it says 64
Yeah.
bytes. That's the reply, 64 bytes from this IP. Let's go to this IP and ask HTTP Hypertext Transfer Protocol to access this IP. I'm giving http://172.217.27.196. There is a public IP now, right? Let me type that and see.
Yeah.
It will load google.com page. Here you can see it will load google.com page. That means if you have public IP and if you are providing a service, web service through a public IP, this Google provide HTTP. HTTP means? HTTP means? Yes? Hypertext transfer.
What's it?
HTTP means? Here HTTP means?
Hello?
Again, you cannot hear me. Hello.
Oh,
Can you hear me?
I can hear bits of what you're saying, sir.
Right. What do you mean by HTTP?
Hello?
Let me type what's the meaning of HTTP? Yeah, you are sending me, right? What's the meaning of HTTP basically? HTTP means
Hypertext.
text transfer protocol.
Protocol.
Right, correct. So if I go to Google and ask hypertext transfer protocol, just give me the service of this IP. Hypertext transfer protocol, please give me service from this IP. Then it will give the reply saying, I am google.com. Okay, that's what really happening in the,
Right.
that's what really happening in the environment. Okay, I'll forward you this note. This is incomplete, but anyway, I'll forward this.
Right.
We'll continue with this note from, actually tomorrow we will continue from this. And the recording I'll email. Can I have your email?
Yeah, sir, I'll send it to you.
Right, please WhatsApp me, then I can send that email. I can email you the recording. Right? Okay, with that I'll stop for today. So now it's 9:20.
Okay, sir.
Let me stop for today.
Mhm.
And let's continue tomorrow. And if you have doubts, please send me via WhatsApp.
Okay, sir.
Right, okay.
Thank you, sir. Have a good day.
Okay, good night.